Hi everybody, this is Bharat, Assistant Professor, Department of Electrical and Electronics Engineering, SNS College of Technology, Coimbatore. So today we are here to see the lecture series video for the course Measurement and Instrumentation Engineering. What is the course we have been discussing about is the concepts of comparative methods of measurement. In the last video, we have been discussed about the various quantities or various qualities and structure of what you call the AC bridges. AC bridges, we have seen already what is Maxwell's bridge and Anderson's bridge. Today, we are going to discuss about what we call it as a Schering bridge. Come, let's get into the topic. This topic is discussed for second year courses, second year triple students. That is the classification of one type of an AC bridge, which is called Schering bridge. When we come to understand the various concepts of bridges, we just studied about the DC bridges, then came to AC bridges. AC bridges, which is used for inductance measurement, capacitance measurement, and frequency measurement. So we have already discussed about Maxwell's bridge. We already discussed about Anderson's bridge. Now we are going to discuss about the Schering bridge. Coming to understand the concept of empathy. Empathy is one of the stage in the design thinking process where we understand why we need, what is the need for understanding this topic, why we need to understand about the Schering bridge. So the precision measurement is the foundation of any technology nowadays. How precise we measure the data. So this also is very important for a Schering bridge. It is used for grid reliability in power system networks. It is used for measurement accuracy and product quality in other type of systems, for safety in high voltage engineering systems, and career growth for electrical engineering opportunities. So this Schering bridge is very important to understand. So various classifications of bridges we have already seen. So AC bridges is having 6 types maximum. We have already understood about Maxwell's bridge and Anderson's bridge, which is used for inductance measurement. Now we are going to deep see into the Schering bridge, where we are going to measure the capacitance measurement, dissipation factor, and high voltage applications. The basic circuit configuration of a bridge is shown in the figure. That is, a Schering bridge is shown in the figure. So this figure represents a Schering bridge as similar to that of the other type of bridges. This bridge is also going to consist of 4 different limbs. It is a specialized for high voltage capacitor testing equipments, high voltage design. You could see the various values of resistances and capacitance connected across different junctions A, B, C, and D. The circuit components consist of the few elements where you measure the resistance R1, R2, R3, that is in the ratio arms, C as the carnot capacitor, C1, C2, C3, C4. Unknown value is taken as Cx and G is taken as the galvanometer. So this galvanometer should read 0 to make the bridge under the balanced condition. The AC supply source is given. So this type of configuration is also called as the diamond configuration or the stage configuration. So you could see the working principle. So measurement of both capacitance and dissipation factor is possible with the help of a Schering bridge. So when the bridge is supplied by a voltage source, the galvanometer has to read 0. Null deflection technique is this technique. It has to read 0. When it will read 0, we can make it to read 0 by varying the variable of variable resistors and capacitors. High voltage measurement capability is available. Standard capacitor determines unknown value. So you could, as I told you about the null condition, which is called as the bridge balance condition, is given by at null, the products of opposite arms is equal to equal. That is, Z1 and Z4 are the opposite arms, Z1 and Z4 are the impedances of the opposite arms, and Z2 and Z3 are the impedances of the other 2 opposite arms. So these two has to be equal. That is, Z1 into Z4 is equal to Z2 into Z3. So from this, we can get an expression to find the value, that is Cx is equal to C1 into R3 by R2. That is the value of finding out the unknown value of capacitor, and finding the unknown value of the dissipation factor tan del is equal to omega into C4 into R4. So this formula is used for the precise calculation of a Schering bridge. We have various applications of Schering bridge in high voltage testing, capacitor testing at HV levels, cable capacitance measurement, and also used for power quality measurement, transformers, insulation testing, laboratory usage and dissipation factors, etc. So practical setup, we can have this Schering Bridge practical setup. We have already discussed this in the laboratory point of view. Safety procedures, high voltage safety protocols is also applicable for this Schering Bridge. So we're coming to the summary. We have just discussed about the various types of bridges, AC bridges, and the various methods of measurement using AC bridges. Here we are going, last case we have discussed about the induction measurement. Now we have discussed about the capacitance measurement using Schering Bridge. So thanks for watching. We will just meet you in another topic. Thank you.